Hello, welcome to the part 3. Let's continue. The next question is immediate food delivery number 2, the medium one. Let's go. Let's zoom in a little, zoom out a little bit. Table delivery. If the customer's preferred delivery date is the same as the order date, then the order is called immediate. Otherwise, it is called scheduled. Okay. The first order of a customer is the order with the earliest order date that the customer made. It is guaranteed that the customer has precisely one first order. Okay. Write a solution to find the percentage of immediate orders in the first orders of all customers, rounded to 2 decimal places. Okay, so here immediate percentage 50%. So we have to find the first orders for each customer. Customer ID, order date, customer preferred delivery date, and order date. So my question is how to find the first order, by order date or by customer preferred delivery date. I think that we should find it by order date. And let's switch to Postgres. So you can find the first order by using window functions or subqueries, kind of manual approach. I recommend to use window functions whenever it's possible. Window functions should be your default approach for problems like this. When you need to find the last date, the maximum salary, a customer with the maximum salary, so it's a very standard interview question. So window functions are your go-to approach. And the second approach, when you first calculate the last date for each customer, and then you use this information to filter the original table. This approach is more manual. So let's start with finding all first orders. So select star from delivery. Here I will put comma, and then I will use rank function, rank over. Here I will use partition by customer ID because I need to figure out the first date for each customer. Partition by customer ID, order by order date, and just like this, order by order date. If you do not specify the type of sorting, the type of ordering, it will be ascending order. So that's what I need. Let's run and check. Wrong answer. And here, if I look at this table, I may see that here I have the first customer, and he has 2 deliveries. This is the first one, this is the second one. And you may see that the first delivery has the rank of 1. So now I can filter it by this rank. And I will call it as rank. I usually call my ranking columns this way. And I cannot use rank in where clause because it is not allowed in SQL. So I have to introduce common table expression. with first orders as, and I will include the subquery here, select star from first orders, and I will check it once more to see that everything is fine. Now I can add where rnk equals 1 to filter only first orders, and now I need to calculate the percentage of immediate orders, and I will use case when for that. I will introduce a binary flag, case when order date equals customer pref delivery date, then 1 else 0, and let's look at this flag. So here it is. For example, this order is an immediate one because order date is the same as customer pref delivery date. And now I can just average the zeros and ones, and I will get the percentage. That's one of my favorite tricks for calculating percentages. As immediate percentage, and I have to round it to 2 decimal places. Let's do that. Round, and here round, comma 2. That's it. Run. Should be it. Percentage 0.5. Here 50. So we just need to multiply it by 100%. When I analyze something like this, I usually stay with fractions. I do not convert numbers like this into percentage. I just don't like to multiply by 100, and yeah, I just got used to looking at percentages in the form of a fraction. Submit. Wrong answer. Wow. Okay, let's see what's wrong. Let's debug it together and find the error. So I will click use test case. Now this test case is here, and I will get rid of the first one, yeah, and I will try to run it, and I should get an error. Yes, here is the error. So how to debug? Let's comment. Let's comment this and look at all rows. So here, what do we have? We have 1, 2, 3, 4, 5 customers. Yes, 1, 2, 3, 4, 4. So here I can see that the order date is this customer has the same order date, but customer pref delivery date is this. So probably I should rank by customer pref delivery date, and that will solve the problem. So let's check it here. Let's change it here. And now I will uncomment it back. Run. Yeah, so I used the wrong date to order. Let's try to submit. wrong answer. Now we have another error. Order date, customer, pre-delivery date. Interesting. So now another test case. Another test case is off. And yeah, here that's my percentage, and here is the percentage from the correct one. I paused the recording and figured out how to solve this question, and I just tried to order by 2 columns. So first one, order date, and the second one, customer pre-delivery date, and this solution passed all tests and was accepted. But again, here they said that it is guaranteed. It is guaranteed that the customer has precisely one first order and no explanation. So this question, the description is a bit off, I think. And by the way, now on LeetCode you cannot see the number of dislikes. Yeah, so you cannot understand if this question is good or not, because previously it was a very good metric, the ratio between likes and dislikes, to understand how good the question is. So yeah, that's how you solve it. You just have to order by 2 columns. Let's look at a couple of solutions, and this question has no editorial, so we'll look at users' solutions. Simple and easiest MySQL solution using in and average. Oh, okay, let's see. Round average, yeah, here order date equals customer pre-delivery date times 100, comma 2 from delivery, where customer ID order date in select customer ID mean order date as first order from delivery customer ID. No, the average is done by sum true values divided by count. Oh, it just he just describes how average works. Okay, do upvote if you like the solution. I like to see this instead of this kitty, you know. Hi, do you use customer instead of delivery ID? Here first order. Yeah, I'm not getting why the average function is used here. Yeah, it's very common, and that's a trick. You should learn it. Great solution, got to learn new things. Yeah, so here I don't understand how this test case passes the situation when we have order date the same order date. So it's kind of randomly passes it. I don't think it is a good solution in this case. But again, in the description, it is guaranteed that the customer has only one first order. But we've seen that customer could have 2 first orders at the same date. Super easy solution. Okay. And no one uses window functions. All solutions for immediate food delivery, number 2 problem. Oh, here is the description, the long round sum. Yes, okay. Count divided by count. So instead, it's you could have used average. Customer ID, order date in. Yeah. By the way, this style I don't really use it often. I usually, if I need to filter by 2 conditions, I use inner join. I just inner join it, but this thing will also work. And by the way, I'm not sure whether it works in all SQLs. For example, what if I paste this solution into Postgres and run it. Run. Oh, have to get rid of this. Around some if. Oh, it has no if function. Yeah, by the way, if as you can see, it is not generic, so it's better to use case when. But let's see if we can just do it this way. Probably it will work without if, just summing true. Some no function matches the given argument. You might explicit typecasts. Select round sum. Okay, so yeah, let's do average. Average, and get rid of the count part. Times run like this. And I think I have to add case when, order date, then 1, else 0 end. Now it should work. Yeah, but again, we do not pass this test case where we have duplicated order date. So I don't understand how it works here. And in Postgres, this style also works. But again, I'm not a huge fan of this style. I usually use inner join. But what if we paste this solution into MySQL just to check it? Will it pass all tests here? No. So this and let's copy the original one just to check. Copy. Run. And the solution doesn't work. So yeah, nice one, thank you. I don't understand how do they use it. Yeah, probably LeetCode has updated test cases and this solution no longer works. So again, the solution with window functions is preferable, this solution, because window function is much better to do this job of finding the first order or the last order or something like that. So I recommend to use this function to solve questions like this. Let's continue. The next question is gameplay analysis number 4, and I solved it in the past. Let's check, by the way, how long ago. Oh, let's get rid of it. Let's get rid of the solution. Submissions, and here let's see. The last time I was trying to solve it was February 16, not that long time ago. And oh yeah, probably I was working with some of my students at this question. Okay, let's do that. Description. So gameplay analysis number 4, the medium one. We have one table, activity. Write a solution to report the fraction of players that logged in again on the day after the day they first logged in, rounded to 2 decimal places. In other words, you need to count the number of players that logged in for at least 2 consecutive days starting from their first login date. Then divide that number by the total number of players. Okay, so again we need to filter the first the first logging attempt. So fraction of players that logged in on the day after the day they first logged in. In other words, you need to count the number of players that logged in for at least 2 consecutive days, starting from their first login date. Okay, so let's first create the table where we will have first login date for each customer. Let's do that. Select star from activity. And I will use rank function again. Rank over partition by player ID, order by event date as RNK, and let's run it. So here we have the first login, login for each player. So this is the first login in for player 1. Okay, and we can filter them now. And I will create with activity ranked as select star from activity ranked where RNK equals 1. Now we have these records. Let's think about the next step. In other words, you need to count the number of players that logged in for at least 2 consecutive days, starting from their first login date. So now I can find the second record, the second activity of each customer, and join it to this table. Let's do that. Second activity as, and I will just copy this thing. And here, and I will, no, by the way, second activity, I will create it like this. I will select from activity ranked, and here I will use it as where RNK equals 2, just like this. Yeah, so here my second activity. Now let's join 2 tables together. Left join second activity on user ID, player ID dot player ID equals second activity player ID. Select star from activity ranked. A second activity, yeah, so let's do it this way. Activity ranked, all fields from this table, and from the second activity I will use only event date, and I will look at it just like this. From activity ranked, from activity select, yeah, just an extra comma is ambiguous. Oh yeah, where activity ranked, I agree. Activity ranked RNK equals 1, correct. And let's see, so here, this is for the user 1. This is the first activity. This is the next activity. And here we can see that it is less than 2 days. So we can count it as, how is it called? Calculate. It's called fraction here. So it's just users who logged in the day after a first activity. This user did not logged in after initial login in, and this user logged in 2 years after. So we do not count this guy, and yeah, it corresponds to this fraction. So here we will count only this one. And let's calculate the difference, and in Postgres it should be pretty simple. So you just do it like this. Second activity minus activity ranked dot event date, and this should give us number of days between these two dates. Yes. And now I can create case when activity less than 2, less than 3, I think, yeah, then 1, else 0, and let's check. Case when a comma, most common mistake when you write SQL query, just forget about comma. Yes, 1, 0, 0, and now I can average this flag, average, using my favorite technique, and I will call it fraction as fraction, and I will get rid of all these debugging steps. And I have to round it, right? To 2 decimal places. Okay. Round here, comma 2. Run. Yeah, so let's try to submit. Wrong answer. Let's debug it. And I want to make the code a little bit more readable. Maybe I can do it like this. Yeah, better. So fraction expected, fraction 23. So probably here should be 2. Let's use this test case and run and check. Yes, let's submit and see. Now accepted. Yeah, and here for me it's for some reason hard to understand this description that it should be less than 2. Yeah, so let's read it one more time. You need to count the number of players that logged in for at least 2 consecutive days starting from their first login date, or 2 consecutive including the first one. Yeah, so again, the description could have been better. Here is the solution. I think it is very straightforward. So first you rank all activities, then you find when I've created an additional table with the second activity, and here I started with the first activity and joined the second activity, and then just calculated the fraction of target events. Let's look at solutions, and this one has an editorial. Cool. Approach: subqueries and multi-value use of the in comparison operator. Okay, so here we create, again we use this compound in. Yeah, again that's the same as the previous question. So here instead of a window function you can use something like this, where with the double condition or an inner join. Yeah, but I recommend you to use window functions because they're much more convenient. And how do they find the second activity? We can use similar idea for this problem again, where again we rely on our ability to access the tuples. Yeah, this is a tuple in some manner. Well, one in player min, but what should val1 and val2 be? We must have player ID as val1, but the choice for val2 is less apparent. Okay, the algorithm: find the first login date, determine which tuples, if any, exist such that days after. Okay, let's look at the final solution. MySQL. That's quite difficult solution. Select count. They do not use average here. They use a subquery count distinct. So here they just calculate the number of all players, and where player ID date sub. Oh my gosh. Oh, I see. Mean event date. I see. Yeah, so this if you do it this way, you don't have to filter out the second activity. Yeah, because no, I don't like this solution because it is very, very cryptic. Let's look at common table expressions and inner join. MySQL first logins, consecutive logins. How select count, inner join activity. Yeah, so that's how they filtered out. So they kind of created the second activity as I did, and then they calculated the fraction itself. But I also don't like this solution because it is very messy, and I don't understand why don't they use window functions. It's a perfect use case for window functions, but at least they use common table expressions. Thank you for that. And here is a very, very bad naming, like I'm I'm sorry, no, here C is consecutive, F for first. Okay, so then okay. I just thought that they used like random letters. And by the way, in the previous solution, they did it. A1, A3, A2. So never name your tables like this. You never give aliases like this, because you will be confused very, very fast. So it's a very bad practice. Let's look at some user solutions, and hopefully we will find something decent. Best optimum solution with explanation. Let's oh my god, I had this kitty again. Please. Select round where, yeah, so they use just solution from editorial. A very simple MySQL solution without join, with explanation, simple solution with the diff, clean solution. Let's see. No window functions, and I don't think it is clean solution. Back, bits, MySQL simple solution with explanation, best for beginners. Self-join, simple common table expressions. Let's see. With interval day, min date. So they also use this date sub, and this in Postgres it's more intuitive, just to you just subtract one from the other, and that's it. As is return, and then they is return count distinct player ID as fraction from CTA. Very bad naming. Player ID. They don't understand what do they do here. Equals min. Oh, they use a window function. So that's how they calculate this flag. Interesting. Yeah, so they calculate the another date and then compare it with the first order date. Yes. Interesting. Sum is return, and then they divide it by the distinct number of players. Yeah, by the way, I like this solution somehow. It's not that clear and structured as mine, but still it's a interesting solution, because here that's the interesting usage of a window function, window minimum function compared with the date from the table itself, and it gives us the number of these people, and then you can just divide it by the distinct number of players. Okay, let's continue. The next question is number of unique subjects taught by each teacher, and it is a new section, sorting and grouping. Interesting name for a section, sorting and grouping. Sorting, probably ranking. Let's see. So let's go. Number of unique subjects taught by each teacher. One table, teacher. Write a solution to calculate the number of unique subjects each teacher teaches in the university. Return the result table in any order. So just count distinct, that's it. Let's see. So, for example, here teacher 1 and 2, and we have here 2 subjects, and here 1, 2, 3, 4 subjects. Yes, just count distinct. Okay, indeed an easy question. Select star from teacher, and here I will use teacher ID, comma, count distinct, subject ID, and we don't care about university, right? Department ID, I mean. They teach subject 2 in department 3 and 4, and teach subject 3 in department 3. Yeah, so here is the duplicated one, right? Yes. Subject 2. The teach subjects. Yeah. So here is the duplicated subject, and we should not count it as a distinct. So copy here, group by teacher ID, and the output should be CNT. I should name it CNT. Here, let's do it as CNT. Run and submit. Yeah, this is super easy. Later, and it has an editorial. That's interesting. Let's see, database. Yeah, so and still people post their solutions. I think easy, fully explained. Easy, fully explained solution for absolute beginners. Yeah, but probably I'm laughing at it, but like when I understood the concept of distinct, it was very cool that it's something that gives you only unique values in the column. So yeah, cool. The next question, user activity for the past 30 days, number 1, and I solved it in the past. Okay, let's see for how long time ago. Oh, it was a long time ago. April 2021. Oh my god. Okay, let's switch to Postgres. User activity for the past 30 days. We have one table, activity. Write a solution to find the daily active user count for a period of 30 days. Write solution to find the daily active user count for the period of 30 days, ending 2019-07-27 inclusively. A user was active on some day if they made at least one activity on that day. Return the result table in any order. Active user day. Active user. Write solution to find the daily active user count for a period of 30 days ending. I don't understand how to use this 30. Probably ending. So if I just put less or equal than this date, probably it will do the trick. Select a star from activity, and I will use what? Activity date, and count again, distinct user ID, group by activity date, and here I will use where activity date less or equal to this date. It's a strange question. Run cancer, activity date count, and I don't. Oh, I see now. 30 days. Okay, so I will just here I have to subtract 30 days from this, and yeah, that's it. Activity date is less. Let's do between. This is the end of the period, and here I will use, can I use it this way, date, and here I will insert this minus 30, and just to check it real quick. Run. Run cancer count. Yeah, so now it is correct, but I have to rename it to active users as active users and day. That should be it. Submit. Run cancer output. Day. Maybe I should any order inclusively. So between should included -30. Maybe let's try submissions here. Use test case. And what if I put 29 here? Oh yeah, now it works. So yeah, if we include it, so we should use 29 here, I think. Accepted. Cool. And let's look at solutions right away. Editorial. Solution and activity date. Oh, they just calculated it manually. That's funny. And they diff, yeah, here, and date diff. Yes, so it's also, it is the same as my logic here. And I think this is better than to hard code it. But this date is hard coded. So between, oh, also, yeah, interesting. I could compare each date with this and calculate the difference between 0 and 29. I like the editorial, by the way. It shows you a couple ways to calculate the difference between dates. Approach algorithm date diff 30. Yeah, activity. And they here they don't use between. They decided to use this. Yes, pretty decent editorial. Let's look at user solution. Just do what it asked step by step. Thank you, Cap. Select activity date as day count. Define the condition. Yes, activity date and activity. Yeah, here he just hard coded. And that's it. And you don't need parentheses, and people usually don't write SQL queries like this. Okay, so that's quite easy question. Next question is product sales analysis number 3. The medium one, by the way. 2 tables. Whoa. Write a solution to select the product ID, year, quantity, and price for the first year of every product sold. Return the resulting table in any order. The result format is in the following example. Sales table, product table, and product ID, first year, quantity, and price. So we need to filter out only the first year. This is it. Right, to select the product ID and prices for the first year of every product sold. And okay, so here we have product ID, first year, quantity, and price. And do we need this table? probably if the product has never been sold, we should return null. Yeah, so probably this is what they implicitly try to tell us, because here of every product sold. So let's assume that we should do it this way. So we should use the product table as our starting point, and then to join first years of each product. Okay. So, and let's start with filtering the first year. Select star from sales table, and I will use window function rank to find the first year, rank over partition by product ID, order by year, partition by product ID, order by year, as RNK. So that's how we rank our products. Yeah, so let's run to check. RNK, yes. So now I will call this table products with products or sales ranked as. And here I also assume that year is unique for each product. I assume that we cannot have two rows for the same product with the same year. Sales ranked over partition by product ID, order by year, and now I can join this to my starting point. Select star from product table, left join sales ranked on product dot product ID equals sales ranked dot product ID, and I include sales ranked dot RNK equals 1, because I need only the first year, and I will include this condition in the join condition. That's very logical. So now I will use product ID from product ID, and I will use what from sales ranked I will use year, I will use quantity, and I will use price. And here I should also rename first year into year into first year. Let's run and see. It's wrong. No. So yeah, here by the way, I didn't notice it when I was analyzing this question. So here this Samsung product is not included in the final table, so we probably don't need the join. We only need this ranking, and that's it. Let's change it from sales ranked. I don't need this, and RNK I will include in where clause. Where run. Select product. Oh yeah, I know I don't have product ID. I will leave it like this. I have only one product ID in this table. Yeah, so seems correct. Submit. Accepted. Yeah, so I kinda overreacted to the description, to this every product sold, because in previous questions it was very important to create a starting point and then join everything to this table to have this nulls. In this case, we don't have to include it. Yeah, so here product ID 300 is not included because there are no sales of this product. Let's examine solutions. Editorial, database. Here again, so they use this technique again with where tuple in where or compound where and subquery. Again, I prefer to do it via inner join and not where. Implementation, yeah, and they do not provide you with window functions solution. And I think that window function solution should be the go-to solution because it's much more intuitive than this. First step, you rank, and then you filter out the first one. Much more straightforward. This is more generic, you may argue, yeah, because some SQL dialects has no window functions. But yeah, I think window function is today you have it and you should use it, and this should be your default approach. But during the job interview they may ask you if you provide a solution with a window function. They may ask you to solve it in generic SQL, something like that, either with where or with join. So also you may also practice this solution. Let's look at user solution. MySQL solution. Same. Window function solution finally, and they use a subquery, classic subquery. I also don't recommend to use classic subquery in cases like that. Even the case is super simple, but still, yeah, it's better to have your code and your query and your logic flow from top to bottom and not inside out right here. So that's the first step where we rank, and then we go outside and do the final step. Here everything is more natural. The first step on top, and then the second step on the bottom, and you read it from top to bottom. Yeah, but we have this window function solution. I'm happy that you can find it here on LeetCode. Okay, let's continue. Oh, new haircut. Cool. So the next question is classes more than 5 students. Let's do that. One table, courses, student and class. Write a solution to find all the classes that have at least 5 students. Return the result table in any order. The result format is in the following example. So here we have math class. And this is a classic question, and I ask this question my students all the time. I think it's about grouping and filtering, and it requires you to use having. Let's do that. Select star from courses. Oh, and let's switch to Postgres. Select star from courses. Then I will group by class. Group by class. And here I will have class count star, because courses student A, B, C, D. Yeah, probably it's better to count distinct student, but let's start with just count star, because this table seems like a table where each row is a student takes some course. And here, by the way, have at least 5 students. Nothing about unique students. So let's run this code to see. And now I need to filter out these classes because they have less than 5 students. And I cannot use count or any other aggregate function in where clause, so I have to use having. Having equals having count star greater or equal than 5. Here it is. Class count, and I need only class, so I will get rid of this debugging column here. Run. Accepted. Let's submit. Accepted. So we don't have to use distinct in this case, but distinct in this case I think will not hurt, so you can use it. And I also like to ask my students a follow-up question, and I call it that's a type of question. I ask it about almost all SQL about almost all SQL problems I give. A Grinch question. A Grinch has come and stolen has stolen having clause. How to solve this without using having? And the answer is through subqueries. So here, if you are not allowed to use having, if Grinch has stolen having, you should do it this way. Let me show you. Class count. Now I will get rid of having, and this one I will call it as CNT. Then I will turn it into common table expression with and I call common table expressions subqueries because they are, but they are just more convenient way to use subqueries. With class CNT s, and now I can do it like this: select star from class CNT where where CNT greater or equal to 5, and here I will use only class, just like this. Run. Accepted. Submit. And accepted. So this is a workaround. So we can imagine that we have no having, and that's how you solve this question without having. Let's look at solutions. Solutions should be very straightforward. Database, group by, and here, oh, interesting, they start from approach group by, and they use my second approach without having, and approach 2 using group by and having. Yeah, so that's my second approach, and this is a decent editorial, I think, because it demonstrates you both ways. I like it. Solutions, and here we will not find anything interesting, I think, except cute kitty, of course. Oh my god. Can you please upvote? No. Can you please not use cute kitty to ask for upvotes? Then probably. Select class courses, group by class, count student greater than 5. Right. By the way, in editorial, what do they use? Count student. Yeah, so here I think that I use star because, again, because of the nature of the courses table. Let's look at another one. SQL to simple solutions. I think that's just a copy of editorial. Yep. Here they use distinct student, as we discussed. Here subquery. Bad name, temp. Yeah, never name your subqueries like this. Name them with a meaningful name, like class CNT. Yeah, this is it. The next question. Find followers count. Followers table. Write a solution that will, for each user, return the number of followers. Return the result table ordered by user ID in ascending order. That's quite stupid question, right? You just count follower ID, that's it. Or again, you can just count star in this case. Select user ID, count star from followers group by user ID order by return ordered by user ID in ascending order. Okay, and here it should be named followers count as followers count. Run. Submit. Accepted. So quite straightforward question. Editorial, and I like that LeetCode has editorials for simple questions like this. Yeah, so count group by, and the editorial is long. Yeah, ascending. Yeah, here they explicitly write that the order should be ascending by default. When you write order by and specify nothing, by default it is ascending. And here they use the semicolon, but again it is not necessary because you are not going to have more than one query here at LeetCode, so I don't see any sense in using semicolon. Solutions from user, cute kitty guaranteed, almost guaranteed I think here. Yeah, so interesting. Let's find it. No, MySQL code. Please upvote to motivate me in quest of documenting all LeetCode solutions. Happy coding. Wow. Okay. Easy SQL solution. No kitty. Okay. Thank you. The next question is biggest single number. Let's try an easy one. My numbers. Num. Only one column. Cool. A single number is a number that appears only once in my numbers table. Find the largest single number. If there is no single number, report null. The result format is in the following example. Interesting question. I like it. Yeah, I like it. So here we have to perform two steps. First step is to count how many times each number appears. Then filter and get only numbers that appear only once, and then finding maximum among these numbers. So first step it will be with having to find the number that appears only once, and the second step will be with just maximum, and I will do it through a common table expression. Select star from, and I like to start with a template, my numbers, then num column, num count star, group by num, run. Here is my counts. Now I can filter them by having count star greater equals to 1. That's how I find the unique numbers. A single number that appears once, only once in my numbers table. Find the largest single number. Yeah. So here is my single numbers 5, 4, 6, 1, and now I have to find the maximum number out of these numbers. And to do that, I will use common table expression with single numbers s, and here I will use select max num from single numbers, and it should be named num. Okay, as num. Let's run. Test result passed, and here it returns null as the question asks. So it seems to be it. Let's submit. Accepted. Cool. Let's check the editorial. Pandas, we need database intuition. So here having, and then they use a subquery to figure out the maximum number. Implementation, yes, this is it. And they do not demonstrate approach with common table expression, and I think this is bad, because common table expressions are much better than classic subqueries, because classic subqueries you should read them inside out, and common table expression you read from top to bottom. Let's look at user solutions. See a lot of emoji, and a lot of emoji is a good predictor of observing a kitty inside of this thing. Let's check. Yes, so you see this is a great predictor. Code select max num as num. Yes, subquery. Cool. 5, 7 easy different solutions. Whoa. And no kitty. Interesting. It's free, you see, without kitty. When the solution is without kitty, it's almost free, you know. Select max, and I don't like SQL one-liners. It's extremely hard to read them. Please don't write your code like this. Then max from num. Oh, okay. So instead of filtering, we can use, instead of a subquery, you can use in. Agree. Interesting approach. Not in. Group by having count numbers greater than 1. Yes, so that's just stupid variation of the first one. Yeah, and not logical one. Using sorting. Sorry. Oh, limit 1. Yes, interesting. Yeah, so this solution uses a trick to find maximum number. You can order something by what you want to find maximum, and then get the first row. I call this approach a hacker approach because it kinda uses technical function of SQL to just cut the rest of the table. But in this case, it's okay. Select if count num null as num from my numbers. Again, sorting, and here query 6 Koaleski. Oh my god, I don't want to parse this question. But I cannot see common table expression. Union all. Oh my god. Select null order by num. It's, oh, I see, union all. Select null. That's just to have null. Order by number, descending limit. Interesting. Okay, cool. The next question, the medium one. Oh, I just clicked twice. Customers who bought all products. 2 tables. Customer product. This table may contain duplicates rows. Customer ID is not null. Product key is foreign key. Okay. Product key is the primary key, table product. Write a solution to report the customer IDs from the customer table that bought all the products in the product table. Return the result table in any order. Write solution to report the customers from the customer table who bought all the products in the product table. And my first thought was to just count the number of products in the product table, and then use this number to compare it with count a distinct product key from customer table. But what if in customer table we have some products that are not present in this table? So this will be a problem. But yeah, why? Probably it's a good idea to start with this idea. So let's assume that customers in the customer table we can have only products that are present in the product table. So let's do it. So select count star from product, and here is the and it is the number of products. The number of products 2. Okay, and now I will comment it for some time. Then select and we have to return customer ID. Okay, select a customer ID count distinct. I will use distinct just to make sure that there are no that I ignore same products and count only unique products per user. From customer group by customer ID. Run. And here, customer ID, I have my counts. And now I can use having and count distinct product key. Having distinct product key equals to this value. I will insert a subquery like this. And I don't need this count in select clause. So let's run it. Yeah, this test case is accepted. So let's try submit. Accepted. So if we assume that in the customer table we cannot have any other products keys, that's okay, and that's what this question wants us to do. But let's imagine that the question is more difficult, that we have to compare product keys for each customer with product keys in the product table. So and the customer should get in the list only if it has all products from the list. Yeah, so let's say in the product table we have 1, 2, and 3. Yeah, and in the customer table products could be anything. And let's say customer has products, let's say 1, 2, and 4. And this is not a match. Yeah, so it should have 1, 2, and 3 in order to get into the result table. So we have to compare these IDs somehow, the list of IDs. And in Postgres and in most other databases, we can use something like concatenation in group by. So you can concatenate the values per customer in this case. And I don't remember how to do that, so I will ask a ChatGPT. And I will provide it with. Actually, I ask ChatGPT to generate this solution, I think. Let's just copy the whole description. Like this. Here. Please generate a solution. Solution that uses concatenation in group by, a concatenation of product keys per customer, and compares of unique product keys per customer, and compares it with the list of IDs in product table. Let's see. To solve this challenge, using the approach of concatenating unique product keys per customer and then comparing it. Oh, I should have asked. I should have provided the name of the database, because by default it started to generate it for MySQL. But these functions, like concatenation per group, are different in different databases. I use Postgres. Postgres. Save and submit. To achieve this in PostgreSQL, you can use query that concatenates all unique product keys values for each customer and then compares this concatenated string to similarly concatenated string of all product keys. Let's see. Varchar, okay. String ag, yeah, here it is. But distinct, okay. Order by product key, yes, that's also very important, the ordering. And here is the query. And I like that ChatGPT uses common table expressions, and yeah, the solution is straightforward. So here in the last step, we compare the list of products with all products keys. And let's copy this solution, and I will debug it for you here to show you how it works. Here I just want to, I will comment this where for a moment, and I will have all columns here just to show you how it works. Oh, PostgreSQL is an aggregate order by must appear in the argument list line. What? Order by product. Probably string ag has no order by clause. In aggregate with distinct order, expressions must appear in argument list. Oh, maybe we have to put comma here. It like that's no syntax error near order. Yeah, but if I can get rid of this. I can get rid of this and run. It should work. But now we are not controlling ordering. So here, can you see that now this customer has 5 and products 5 and 6, and the all products keys are 5 and 6. But how to do order string ag? Let's provide ChatGPT with this error. I will use the original code, and then I will ask ChatGPT. I will give it this error. I get this error. Given the error you encountered, it appears PostgreSQL enforces that then using distinct inside an aggregate function like string ag, the expression used in order by must also appear in the aggregated expression. But yeah, order by. Oh, so yeah, here it wants this to be included here. Included. Oh no. Group by customer ID, and I cannot see the difference. Or group by. No, I cannot see the difference. Must also appear in the aggregated expression. The constraint can complicate the intended approach of sorting the distinct product key values directly within string function. As a workaround, we can first create a subquery or CTA to ensure that the product key values are distinct and sorted before they are concatenated. This approach involves an extra step but achieves the same goal. Here is how you can adjust the query to work around this limitation. Group by distinct. Oh, so first they get distinct. Yeah, so we avoid using distinct together with order by. Let's try. Run. Yeah, and it works. And let's submit it just to see if this solution is accepted. Yes, accepted. And I want also to look at the table without filtering, just to see that it does what we want it to do. So here is the final table that we then filter. And again, we have the list of products that customer has and the list of all products. And we just then compare two strings and get the desired customer's ID. Let's look at solutions. Editorial. Solution algorithm. Here count distinct product key equals yes. So that's my first solution. Use the nested subquery with Cartesian product. Wow, that's the long description. Let's see what's going on here. Select distinct customer ID product key from customer product. That's how they achieve Cartesian product. Yeah, so they create a template where for each customer, we have all products. And then where customer ID product key not in, select customer ID product key customer. And oh my God, we use kinda nested not in. This is not in. This is quite twisted solution. But this solution achieves the same goal. It compares the product keys and not just counts. And I was thinking about something like that, but I decided to proceed with my approach like this, with comparing the list of products after concatenation. This approach is interesting as well, but the number of subqueries are crazy here, and it's so hard to untangle it. By the way, let's untangle it using ChatGPT, and we will create we will rewrite it with common table expressions, and you will see that it will become much clearer. Rewrite using CTE. To rewrite the provided SQL query using common table expressions for clarity and better structure, you can follow these steps. Okay, so we have to read this kind of explanation, but I just wanted to see the code. Here is the query. All possible cases. So again, here we create a template, and I like that ChatGPT rewrote it with cross join and without this style. When you just list your table in the from clause. It is not a good idea. It's kind of old style of SQL, and I don't recommend to use it. Better, you should better use cross join. Okay, so we created a template. Then, not purchased products. So then they select from all possible cases and not purchased products, customer ID. Okay, yeah, so they create a list of customers who bought not all products. Yes, I understand it. But after this, we should have duplicates, I think. So probably here we may also add distinct. Then customers with all products. Customers with all products. And here the last one, they just select it from this table. So this step is not necessary, strange step. And for me, this where is not really intuitive. So I think that it would be better to use inner join to filter these customers. Let's ask ChatGPT to rewrite it with inner join. Rewrite it with inner joins instead of where, because if we will use inner joins, we will not have to use additional subqueries, and the code will be more clear. Inner joins instead of where in. To rewrite the original query using common table expressions and replacing the where not in clause with an approach that utilizes left join. Okay, yes, left join in this case because we are filtering out clients who are not there. Yeah. Where? Yeah. So can you see now that we don't have any subqueries and the logic is more straightforward. All possible cases, then not purchased products, and here we left join our customer table to all possible cases, and we observe customers who has not bought all products, and then we use this information to get the final result. And we use another left join and same logic. I think this is much more clear than the solution from editorial, because it uses common table expressions and left joins instead of where clauses, and that gives us that spares us from using subqueries. Let's look at user solution. By the way, that's a demonstration of how you should understand the solution yourself. In many cases, you have to untangle the solution to understand it. And please use ChatGPT to help you. And the first step is usually to ask to rewrite using common table expressions instead of subqueries. And after that, everything will become clear. And also ChatGPT can provide you explanation step by step here what's going on. And you may also ask specific questions about a specific step. So can you see how powerful this tool is? Solutions. Let's check if the emoji predicts kitty. Yeah. So now accuracy is 100%. Here the simple solution with count distinct, again without comparing the list. Simple solution with two-line query. And kitty again. Here having, yeah. And let's see if anyone implemented most posted solutions are wrong. Solutions are wrong. That's very heavy accusation. Here distinct customer from customer ID, and here customer. Yeah, so this this solution compares two lists. Okay, most posted SQL, easy to understand. Medium, top 2023 explained, a lot of emojis, so kitty should be no kitty. Hello LeetCode fans. Simple MySQL pandas. Natural language solution. Oh my god, let's see. Here is the man. Oh yeah. And the solution is it's so mysterious, natural language solution. And I see it for the third time right now during this walkthrough. We have to choose customer. Maybe someone should ask why natural language solution. It's interesting, but okay. The next question and the next section, advanced select and joins. Oh. And the first question in this section is the number of employees which report to each employee. Okay, let's see. Employees table, employee ID, name, reports to age. For this problem, we will consider a manager, an employee who has at least one other employee reporting to them. Write a solution to report the IDs and the names of all managers, the number of employees who report directly to them, and the average age of the reports rounded to the nearest integer. Here is the table, reports to. So basically this ID is the manager ID. Yeah, so here we have Hersey, and Hersey has two reports, Alice and Bob. Yeah, Alice and Bob, Hersey, two reports, average age 39. And yes, I think we just group by reports to and average the age. That's it. And then we have to oh yes, the problem is that we have to find the name of the manager, so we will have to join this name. So yeah, so let's perform the first step. Select a star from employees, reports to count star. Yes, star is okay, and average age, and we will round it to the nearest integer just by using round. And let's give it the proper names right away. Reports to count as report employee employee ID. We have to rename it to this as employee ID, and let's break it into several lines. Reports to employee ID, count reports count, and average age as average age, and of course group by reports to. Let's debug. Here we have null 9 to 39, and we have to get rid of these nulls. So where reports to, or I can, by the way, I can use then inner join actually. Yeah. So let's create this thing, this table as with managers as, and then I will select star from managers, and here I will use inner join original, and I will join the original table employees on managers employee ID equals employees employee ID. And this inner join will help us to filter out nulls from the employee ID, because you cannot join two tables by nulls, and they will be just filtered out. And here I will use let's say managers employee ID. Then I need to provide a name from employee.name, then managers dot reports count, and managers dot, oh, as average, here is the mistake, average age, a typo, average age, that should be it. Let's check on these test cases. Select managers, column managers that not exist. Oh, because it is, yeah, just employee ID. I need employee ID here. Run. Accepted. Here, submit. Judging. Wrong answer. Okay. What's wrong? Expected. Probably I should sort it somehow, yeah. Ordered by employee ID, oh yeah. Order by managers employee ID. Submit. Bam. Brilliant. Later. Accepted. Cool. Let's look at solutions. Editorial. Database. Approach. Self-join. Do I use self-join? In some sense, yes. But I prepare the table in advance. What do they mean by self-join? Where is the implementation? Oh. Okay, let's see. Employees emp join employees MGR managers. Okay, so that's how they filter managers by inner join. Smart. And then they perform basically same operations as I do. I think I like this solution. Yeah, so it allows you to not use additional step, but my solution is easier to understand, because here you have to kind of grasp what is happening here, that we are filtering because of inner join, and this allows us to perform this aggregation right away. And here first I calculate our information for managers, and then I get the name from the employees table. Interesting. Correlated subquery. Oh, this I hate these things. And I'm doing SQL for like, I've been doing SQL for more than 10 years, I think, and I've never understood this, honestly. Let me demonstrate. So here, what a correlated query is. It's the query that looks outside of itself. And here my mind just so reluctant to read it. Where is as name, here is the subquery, and this is the correlated subquery. Oh, so that's how this that's how we get name instead of a join. You see, name, and here it is. So we name the table inside the subquery E1, by very bad name, by the way, as you know. Yeah, so E1, E2, E3, etc. It's super inconvenient and super like bad names. No. And the thing is that the where uses the outside table E. So basically, this thing is a join. And this is the same approach as my approach, but I use common table expression instead of this crazy correlated query. And I don't recommend you to use correlated queries because they're absolutely cryptic. Let's look at user solutions. Quick check for a kitty. Yes, of course. And yeah, it's the same person, I guess, right? Yeah. Easy, fast, fire, clean solution, star. Wow. Around average age on employee. Inner join. Yeah, so here is the first solution from the editorial. Simple MySQL solution using self-join. Self-join. MySQL, fully explained MySQL solution. Wow. Inner join. And can you see that almost no one uses common table expressions? I don't understand why. They're so much better than subqueries. And yeah, I think that you should avoid subqueries whenever it's possible. For some reason here at LeetCode, in user solution and in editorials, no one teaches you to do that. That's super strange. Because in real work, you will never use subqueries, and you actually will not use common table expressions as well. You will create actual tables instead of creating kind of temporary tables. Because it is convenient when you work with real data, these queries, these steps could be quite heavy, and you will have to wait again and again after rerunning the query. So it's better to store them on a hard drive and just access them as a table. And if you if you work with common table expressions, it's more natural. Yeah, so this approach is ready to be transformed into creating tables. But subqueries, first you have to untangle them as we did here, and then you can convert it into these steps with creating actual tables. So yeah, it's just strange to me that everyone uses classic subqueries. This is the end of the third part of LeetCode SQL 50 walkthrough. Thank you for watching. See you in the next one. Bye bye.